All right, so for your warm-up, this is something you know how to do. Don't overthink it. You can do that. Then think about the rules that you apply to do that. The same rules apply over here, and see if you can use them to do this one, okay? So I'll give you another minute to work on these, then we'll go over your homework. Okay, so we talked about last class multiplying and dividing. Those are not our only operations. We also add and subtract fractions. So very similar in that we're going to take what we already know about fractions and just apply the same rules, right? We're going to shift our thinking a little bit in terms of breaking down instead of building up, just like we did before. Because the name of the game here is factor and cancel. That's our best friend. So building up doesn't really help us as much as breaking down, okay? So, I mean, classic way to do this is just say, hey, I see what? I'm trying to add, I know I need common denominator, same bottom, right? And once I see that, I can just do what? You just add the top, so that's 7, 1 plus 7, that's 8. And do I add the bottom? No, you just keep the bottom. So I have 8/12. And then I'm like, okay, I did the work right, but I always check if I can simplify. And I would say, oh, 4 goes into both, right? So then I would divide them both by 4, and I get 2/3. Now, nothing wrong with that, right? What I want you to do is shift your thinking a little bit. It's the same process, just a little different. And when you get to this point, right, I want you to break them down. So 8 breaks down into 2 times 2 times 2. And then 12 breaks down to 2 times 2 times 3. And then I see what cancels, right? And I'm left with 2/3. Now, was that necessary here? No, but it will be with polynomials, okay? That process of breaking down and canceling. So if we understand it here, it's sure going to help us over there, okay? Now, here we go. Now, what do I always check for? Do I have a common denominator? Do I?
Yes.
Okay, so the rule says add the top and keep the bottom. So I'm going to keep the bottom. And then I have, what am I adding?
3x plus 12.
Are they like terms? Can I combine those? No. When there are no like terms, I just write them both. 3x plus 12. Okay, so I did the work. Remember, when we did the work here, we didn't stop. We said, hey, can I reduce? Can I simplify? And this method, it calls for factoring, breaking down, seeing if anything cancels, right? So let's do that. Looking at the top, can you factor, can you break that down? Yeah, what comes out? So it's 3 times x plus 4, right? And then the bottom I have x plus 4. Hopefully you see where this is going. And then even though there aren't parentheses, we know that there are some imaginary ones, right? So we can think of that as a group. And groups can cancel as a group, right? So cancel, cancel, and the answer is just 3, okay? Now, we're going to talk about when you have common denominators on the front of this page, and then on the back, we'll talk about uncommon denominators and what do you do in that situation. But first, let's get these rules locked in, and there's a little wrinkle with subtraction. So let me get that written down. Okay, so our steps, right? And again, these may seem like, yeah, I know how to add fractions, but when you really know the rules and you're consistent with them with polynomials, it'll help you, okay? So our first step is we always, in our brains, confirm what? Common denominator. We just say, okay, make sure common denominator, right? I can't move forward until that is in place. So we confirm the common denominator. If it's not, we'll deal with that in the back, okay? Then, once I know I can move forward, I do 2 things. What are they? I keep the denominator, and yep, and then I add or subtract, depending on what it says to do, the numerator. Okay, now I'm going to add a little star here. If you subtract, and underline this part, distribute the negative. Okay? And you'll see what I mean when we get to that example. You have to distribute the negative. Okay, I'll explain why. All right, once I've distributed, I brought it all together, I'm done, right? Just like when I had 8/12, I was done, right? No, I always check if it can be simplified, and we use factoring to help us with that. So I simplify by factoring and canceling. Okay? So we'll go through another addition example, then I'll show you what I mean with subtraction. Okay? So, everybody got those? Okay. All right, so confirm common denominator. Yes. So I keep it, right? So I just write x squared plus 2x minus 3 on the bottom. Okay? On the top, what am I going to do? Just add across, right? So 4x plus, and then x minus 5. Now, if I have a plus in front of a parentheses, does it do anything? No, it's like having a positive 1 distribute. Like everything just stays the same. So you actually don't need that parentheses right now. But I included it because it's good practice, because when you have a negative, it's going to be different. Okay? You'll see. Okay. So now I combine my like terms. What is 4x plus 1x? 5x. So 5x minus 5 over x squared plus 2x minus 3. So again, just like 8/12, we've done the work, we brought it together, but we check. Can I factor? Can I break it down? Can I cancel? And maybe I can. So I look at the top. Anything factor there? 5, and then that leaves me with x minus 1. On the bottom, this is a magic x, right? And I end up with, anybody know? Yep, exactly. And by the way, there's always a little hint. If your teacher wants you to cancel, he probably gave you one of them already up top. Right? Not always, but sometimes. All right, so x minus 1 cancels, and I end up with a final answer of 5 over x plus 3. Okay? So that's your process. Bring it together, factor, cancel. Now, in this case, we said we keep the denominator if it's the same denominator? Yep. So I'm going to keep it. I got 45x plus 81. On the top, I'm subtracting. What am I subtracting? Minus x minus 5, the whole thing, right? So if I'm subtracting the whole thing, I should treat it that way, right? 6x plus 4 minus the whole thing, x minus 5. Now, I know that I'm going to tell you to do this, put it in parentheses, but we like to skip steps, and we're apt to make mistakes, right? Please just put those parentheses. It'll remind you to distribute that negative. Now, why did I need that? Well, if I didn't have those parentheses, right? And I like to give examples with numbers because that's more clear, right? Let's say I had 5, 6 minus 4, 6. What would that be? 1, 6. So we agree that that's the right answer, right? Okay, now let's say it was written a little differently, right? Let's say it was written as minus, and then instead of 4, 6, I wrote 2 plus 2, 6. Right? Isn't that the same thing as 4? Right? So I haven't changed the problem, right? Just changed the form. All right, now let's say I forgot parentheses, and I just said keep my denominator 5 minus 2 plus 2, right? Well, I would have 5 minus 2, which is 3 plus 2, which is 5, 5, 6. Is that the same as the right answer that we got before? No. So be careful. Do not, if I put parentheses here, I'm all good, right? 2 plus 2 is 4, then I subtract that from 5. Now I have the right answer, right? So it's important math to do. Okay, so now let's keep going. So I got 6x plus 4 minus x, and then what? Plus 5, right? Minus 5. Okay, over 45x plus 81. Okay, let's combine some like terms. What do I end up with on top? 5x plus 9. And then on the bottom,
it's 8. No, it's 9 and.
So what goes into both 45 and 81? 9. So I'm going to pull out a 9. And when I do that, 45 divided by 9 is 5x. And then 81 divided by 9 is 9. Okay. Can I cancel the two 5x plus 9s?
Why?
So all day I've been asking, like, half the class says yes, half the class says no. Who says yes? Who says no? Okay. Why not? Yes, there are invisible parentheses, right? There weren't parentheses around that x minus 5, but we knew they were there, so we added them in when we needed them, right? There aren't parentheses here, but what's being divided? The whole thing is being divided. That makes it a group, and you can add parentheses, and now you can cancel, right? And you actually could just cancel without them, but that really proves it, right? You can. Does that make sense? Okay. All right, so then what do I have left on the top? 1, and what do I have on the bottom? 9, right? Never forget your invisible parentheses, right? Okay, what I want you to do now is do the next two problems, if you haven't yet, and then I'll circle back when we get to the back side, when we're talking about unlike denominators, okay? I'm about to go over it. All right, let's go over these. All right, here we go. Now, common denominator? Okay, so I'm going to keep the bottom. 4x plus 36, and on the top, I just do this minus this, right? There's no group here, so I don't need parentheses. Now, you got to remember all the tools in our bag, right? What's on the top? Perfect square, difference of perfect squares. The trick for that, right, this is why we reviewed factoring last week, is you just factor into two binomials, right? Square root this. Square root of x squared is x. Square root of 81 is 9. And then you do minus plus. Okay? On the bottom, what goes into both 4 and 36? 4. So I'd say 4 and then x plus 9. Do I see anything?
Yes.
Boom. And I end up with just x minus 9 over 4. Good. All right, real quick. Next one. Okay, same denominator?
Yes.
Perfect. We keep it and we add the top. X plus 8. Now, what do? X plus 4 on the top. And, oh, sweet. I got x and x. I got 4. That goes into 8. I'm in business. I can start canceling things, right, Jason?
Nope.
Why not? Yes. There are imaginary parentheses around this and this. And those are like force fields that protect the group, right? If you're outside those fences, you're fair game. If you're inside, you better find an exact group. Make sense? Okay. Common thing that people get tripped up on. Okay, unlike denominators. What's that? Oh yeah, that was the final answer. Question.
Why wasn't this group then?
X squared minus 8?
Yeah.
I didn't cancel it. I factored it.
Oh.
Factoring is okay. Okay, this situation. Okay, now again, we have our way of doing things. We're like, oh, I want to bump the 7 up to be 21, right? Because I need common denominators. So what do I need to do here? I multiply it by 3. So I do times 3 times 3. I get 15 21st plus 13 21st, which is 28 21st, and then I go from there, okay? I want you to think about it slightly differently, okay? Because this will help you with polynomials. Okay, instead of bumping up, let's break down first. So I got 5 over 7. That can't break down. Those no. But 13 over, what is 21 broken down? 7 times 3. Okay, let's say I didn't know what to multiply by. Well, now I can see it right here because I see something missing on this side. What's the factor that's over here but not over here? 3. Therefore, the only thing I need to do is put it over here too, right? So if I put a 3 here and a 3 here, right? Now I'll have the same bottom and I can bring it across, okay? So what I end up with is 15 plus 13 over 7 times 3, which is 28 over 7 times 3. 28 becomes, what does that break down into? 7 cubed. 7 cubed?
Oh, I mean,
7 times 2, right? Over 7 times 3. And what cancels? The 7s. And I end up with just 4/3, okay? Now again, you might be like, well, all you got to do is multiply by 3 and then divide by 7 at the end.
No, but then it gets more confusing.
If you have x's involved, this breaking down is going to be your friend, okay? So we'll practice it, and then we'll look at examples, and then we'll be done. Okay, so again, I'm going to break down first, right? So this is not going to be 3 over x squared. It's going to be 3 over x times x. And then I don't have to think what goes into what. Does that go into that? I just say, what's over here that's not over here? X, right? So I just add it. And I add it by multiplication. I can't just do that. I got to do the top, yeah, right? You can't just multiply the bottom if you're not going to multiply the top. Why? By the way, anyone know why I can multiply this by x over x? And
This is going to be ungrouping.
Because it's
it can
going
always
to
be
cancel.
simplified back down.
it could always be simplified back down. When I multiply by x over x, what am I actually multiplying by? 1. Right? I'm not changing anything. Multiplying by 1 doesn't change anything. Okay, so 2x over x squared plus 3 over x squared is 2x plus 3 over x squared. That one we can't factor and break down any further. That's your answer. Okay? All right, so there's an extra step here that before we get to those common denominators. So let's write down our steps when we have uncommon denominators. Ready? Okay. Your first step is first factor all denominators. So I need to break down everything on the bottom so I can see all the pieces, right? And then I'll know what piece is missing where, okay? Once I've broken down all the denominators, step 2 is determine what factor, and I'll put a little s in parentheses in case it's more than one, what factors are missing. Right? Once I figure that out, I use multiplication to put in my missing factor or factors. Now, once I do that, once I have the same factors on the bottom of both, what will I have? common denominators. So at this point, common denominators use add, subtract steps, right? The ones on the front. So to get common denominators, you have to do a couple things, but then it just becomes like the front, okay? So we have a couple examples to look at, okay? Now remember what we did here. We said, oh, I got 7, and then I have 7 and 3. So I got to throw in a 3, okay? Keep that in mind as we look at this next problem. Here, now before I even begin to try to combine these, well, actually the first thing I do is say, common denominators? No. So then I know that I need to mess around with this a little bit. Before I try to add anything or figure out what goes into what, I break down the denominators. So 7, and then on the bottom, I'm going to factor 3 out, right? And I get 3 and x plus 4. And over here, I have 2x over x plus 4. Now I don't have to see, does that go into that? Does that? I can just say, hey, what's over here, but it's not over here? 3. So I'm going to add it by multiplication. So really, I'm going to multiply it, right? And if I do that, I have to do that, right? So I end up with 7 over 3 times x plus 4 plus, what's on the top now? 6x over 3 times x plus 4. And now I'm back to the problems on the front. I have common denominators. I just bring it together. I have 6x plus 7 over 3 times x plus 4. Now, I always check, can I factor and simplify? But 6x and 7, not much to work with there. All right, one more problem. Ready? This is where it gets a little confusing, so we have plenty of time. Don't worry. Yeah, question?
Are you able to like?
Should I multiply this back out? Yeah. This is no better or worse than if you just said 3x plus 12 on the bottom now, right? That's okay. But I wouldn't require that if you want to leave it like that. Okay. All right. So again, think about our steps the whole way. First, I ask myself, hey, do I have common denominators? No. So now I know before I'm even going to start, I'm going to break down, factor the bottoms, right? So if it's already factored, I just leave it. So 2 over x plus 6 minus, and then over here I have negative x plus 2. And then on the bottom I have a magic x, right? So what does this become? Anybody know? So I need negative 12 to multiply, add to 4.
Positive 6 and negative.
X plus 6 and x minus 2. Now, I know there were no parentheses here, but there are imaginary ones, and that might help you see. What's over there, but it's not over here? The whole thing, x minus 2, right? If there was an x minus 2 here, we'd be in business. So we add it, or I should say multiply it. X minus 2. Now, if I multiply the bottom by x minus 2, top. And you get a distribution situation here, so be careful, right? Because 2 times x minus 2, that 2 will distribute through, right? Okay, so then I see where I land here. On the top, I have 2x minus 4, and then I have x minus 2, x plus 6. Here, minus, and then I have negative x plus 2 over x minus 2, x plus 6. Now, you notice I played with the order a little bit, right? Just to make them look exactly the same. You could do that. You could flip their order. It doesn't really matter. Multiplying, you can always change order. I just made that so it really looked the same, right? Don't necessarily even need to do that. All right. Now, we have subtraction, right? So this is from the front. You keep the denominator, right? X minus 2, x plus 6, and I do what to the top? You subtract. So what subtracts from what? 2x minus 4 minus parentheses negative x plus 2. Right? If you forget those parentheses, you'll get a different answer, right? It was negative x plus 2, so now, oh, I hear what you're saying. Okay, so it's 2x minus 4, and then what's minus minus x? Plus x, and then minus plus 2, minus 2. And I get x minus 2, x plus 6 on the bottom. All right, let's combine a little bit. What's 2x plus x? 3x, and then negative 4, negative 2? Minus 6 over x minus 2, x plus 6. Beautiful. I did the adding and subtracting. I always walk away right after that. I never check for anything. Ooh, we check if we can factor and cancel, always, right? And I look at the top and I say, wait a minute. 3 goes into both. So I'm going to pull out a 3, see if that helps me. 3, and I end up with x minus 2, and then I have x minus 2, x plus 6. So then, cancel, cancel.
The answer would be 3 over x plus 6.
Beautiful. Great job. Okay, so let me hand out your homework. So on your homework, so you were factoring in order to simplify. So remember we talked about how we factor by canceling with these, right? So we need to break down a lot of the time in order to see what cancels. Now, breaking down can mean different things. Breaking down here could mean turning a 6 into a 3 times 2. But breaking down here could mean using GCF. Breaking down here could mean magic X, right? So we factor many different ways, right? So you need to think about the different ways for each situation. Sometimes you have more than one way in one problem, right, at the same time, okay? So this is what we'll do. Talk basics, and then we'll go into the different types and where they're mixed together, okay? The basic idea is, hey, if I was to break this down by factoring, then I don't really need to think what goes into what. I just cancel what I see on the top and the bottom, right? So this is a simple example, right? If I just say, okay, this, I know it becomes one big fraction. I got 3 times x times 7 times x. On the bottom, I have 7, and then 6, I'm going to break down to 3 times 2, okay? This might not be necessary for some people, but it does help if this is your process all the time, okay? Now that I've broken it down, I don't need to think about what goes into what. I look for exact matches, right? So what do I see on the top and the bottom? 3, 3, 7, 7. And now I just roll up what's left. X times x is x squared. On the bottom, I have 2, okay? You could have gotten that a different way, but that's fail-safe, right? It can work anytime.
Can you do number 2?
Sure. So then you start getting into situations where it's like, okay, this isn't a breaking down of numbers. This is breaking down polynomials by factoring, right? So you would, same kind of process. You think about what you can break everything apart into, one piece at a time. Now, 1, if you have a 1, you can almost ignore it because 1 times anything is itself. So here, I'm just worried about this part. Now, this isn't a number I can break down. It's a polynomial. I break that down by factoring. In this case, I can break it down by, yeah, I can pull out a 2. And this is, think about it, and now I turned this into the multiplication of different things. Just like I took 6 and I turned it into 2 times 3. Well, now this, oh, no, it's not 10. Now this is 2 times p plus 5. So it's the same process, but a little more complicated because it's a polynomial. And on the bottom, I have this times this. Now remember, these are groups. Anytime you have something on the top or the bottom of the fraction, there are invisible parentheses around it. So this becomes p plus 6 and p plus 5. And because I've broken everything down, I don't need to think about what goes into what. I just look for exact matches. Now with groups, the only way to cancel a group is to cancel the entire group. right? So I can't cancel it unless I see an exact copy of the whole group, and I do. This and this are exactly the same. So I can cancel the whole group, and I end up with 2 over p plus 6. Okay? That's your general concept. Now, that was GCF, right? So we've seen numbers breakdown. We've seen GCF breakdown. We also will have magic X breakdown, right? So let's look at this one. Here we go. Somehow this whole thing becomes 1. Let's see. Okay, so I make one big fraction, right? And then I look at each piece. I say, okay, how do I break this down into the multiplication of things? That's our magic X, right? So you can do it. You don't have to do it. You can do it in your head if you want to at this point. But essentially, you're trying to find this thing where you multiply and add, right? 2 numbers that multiply to give you 36, add to give you 12. 6 and 6. So I would say x plus 6 times x plus 6, and then that's this piece. Now I bring in this piece. Remember, anything on top or bottom of fractions in parentheses. So I just put x minus 7. Okay? I multiply it all out, one piece at a time. On the bottom, this is in parentheses, so it comes along with parentheses. This is another magic X, right? So you'd get another situation where it breaks into 2 polynomials, 2 binomials. And in this case, I would end up with x plus 6 and x minus 7. Now, I've broken stuff down all the way. I just see what cancels. It turns out everything. This, 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 this. If everything cancels, you got 1 over 1 or just 1. Okay? So those are we've covered the 3 types, right? Now they get combined into the same problem. Question?
So if you cancel everything, why isn't it 0? Because there's nothing.
Well, imagine there was still something left on the bottom, right? Imagine it was like x plus 2 was left on the bottom, but we canceled the whole top. What would we put up top?
1.
No, we always put a 1 when we have something missing, right? Well, this time, everything canceled, and the top and the bottom, so it's 1 over 1, right? If it was 0, then 0 divided by something would just become 0, and that would change things. 1 doesn't change anything. Good question. Other question. Okay. Now, what other ones do we want to see where they kind of started getting combined? Well, the Backus division, let's hit one more. 5? Sure. Okay, so 5. Okay, again, each one has its own factoring task, right? So I look at one at a time. This one right here, right? I'm going to make one big fraction, but I'm going one at a time. I look here and I say, what goes into both of these? What GCF's out?
15m.
Well, 15 does go into 35, but 5 goes into both. So 5 comes out, and then m squared and m comes out. Okay, I don't like my fraction line. Okay, so 5m, and then I get m minus 7. 3m minus 7. Okay. All right, so 3m minus 7. So that's the first piece, right? And then remember, it's multiplying by the next piece. So there's multiplication here. There's also multiplication here. That's what factoring is, right? I'm just multiplying everything at this point. And then I look at this situation. What comes out of everything there? 4 and m squared. And I end up with m minus 9. Okay. And again, we're just multiplying, 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 multiplying. Now on the bottom, this, what happens? It stays, but it's in parentheses, right? M minus 9 times this. Anything come out of here? 10 comes out. So I got 10 and then m minus 7. 3m minus 7. Sorry. Okay. Now, remember how I said breaking it down all the way can be super helpful, right? This ain't broken down all the way, right? Aren't there numbers that can break down further? What can break down a little bit more? Just looking at the numbers.
5 and 4.
Well, 5 is 5. I can't divide anything. But 4 can break into what? Whoa. So I'm going to change this 4 to 2 times 2. And squeeze it in there. And 10 becomes 5 times 2, 2 times 5, doesn't matter the order. Now, why did I do that? Because it's going to be, now I don't have to think what goes into what. I just cancel what I see on the top and the bottom. Okay? Question?
I figured it out.
Okay. So then I start. 5. Is there any 5 on the bottom? Yes. M. Is there any M on the bottom? No. 3m minus 7. Yeah. 2. Yep, there's 1, 2 on the bottom. Another 2. No. M squared. M minus 9. Yes. Okay, so this is really like a lot to cancel, a lot left over. It might be worth just writing what's left over in this case.
What does the answer be? Oh.
This, this, this. Anything on the bottom? No. So what I end up with left is m times 2 times m squared and nothing on the bottom. Now, what is m times m squared? M to the third, and then I end up with 2m to the third. Okay? Just one step at a time, see what cancels, it'll simplify itself out for you. All right, let's go to the back. So on the back, it's division. There's a little extra step, and then it becomes a multiplication problem, and then you're off and running. So what problems do we want to see on the back?
12.
All right, number 12. Okay, so before we can begin, there's a rule that we need to follow. It is keep, change, flip. What do I keep? Yep, so 9p plus 90 over p squared plus 2p minus 48. And then what do I change?
Sign.
Multiplication. And then what do I flip?
Next one.
Second fraction, so I end up with 4p squared plus 32p over p plus 10. Okay, if you do this correctly, it becomes just like the front. We got one more multiplication problem to do, right? So same process. I make one big fraction, and I look one at a time. 9p plus 90. A 9 comes out, so it's 9 times p plus 10. Times 4p squared plus 32p. Yep, 4p comes out. And then I have p plus 8. Okay? On the bottom, I have magic x. So this becomes 2 parentheses. And what are the two numbers? P plus 8 and p minus 6 times, and then p plus 10. Now, remember before I said, did we break it down all the way? Now, you could break this down to 3 times 3 and 2 times 2, but think it through. Is there even any numbers on the bottom? No, so that's kind of extra steps, right? If you did it, it wouldn't hurt you, but we don't need to right now. Okay, so I go across. Any 9 on the bottom? P plus 10? Yes. Any 4? Any p? P plus 8? Okay, so then I kind of evaluate what I have left. On the top, I have 9 times 4 times p. 36p. On the bottom, I have p minus 6. Oh boy. P and p. 36 and 6. Those look real cancelable. But why can't I?
Oh, because it's already simplified.
This is in a group. It is locked. These parentheses are a force field protecting it from being canceled. The group does not like to be canceled without the rest of the group. You can cancel a whole group because they stay together, but you can't just cancel apart. Okay? All right. All right, are we ready to go to the notes?